what this is talking about, this talk is talking about is, as we mentioned yesterday, a lot of our activity with the inverse scattering series, the inverse scattering series, which is very complicated in trying to do everything, and divided up into parts that are useful. So we have a forward series. We have the forward series in the elastic. A reasonable question is, can we model a fully elastic wave by selecting within the forward series, forward elastic series, P-only experiences, but where the P wave at every juncture has full connection with all elastic activity. You just don't follow what, you don't go from P to an S. You stay selective on that history. So I'm going to go very fast on that. Then Xinyu is going to show you a first early test with a single interface, finite difference versus the first term in that series, and we'll move on. So I'm just going to say in words what each slide is saying, and then so that's saying that there's a formalism written in 2D and 3D isotropic heterogeneous elastic. Why ray theory you can select, finite difference in general wave theory you can. We'd like you to do wave theory select. Previous to this, Chris Innanen, who we'll be seeing more of in our collaboration, I'm happy for the work with Cruz, did this kind of work, did a paper on this within the acoustic world, how to predict a primary. So we're saying, can you take an elastic world and not just build primary, build everything, but only P. So the breakup of the series is why it gives you this opportunity. The forward series, the inverse series, there's all these little parts, so you can select parts that interest you for part of its activity. That's basically the story. And it says why inverse scattering is interested in RTM people are interested in modeling, yes, accurate modeling of depth. So, and there are many times that you are forced to run an elastic finite difference when you're really not interested in all of it. Okay. I'm not going to belabor all this. But here are the equations. In other words, you can write the elastic or heterogeneous equations in displacement, and then you do a transformation to P and S, and at some point it becomes this form. In other words, the equations are coupled because they're heterogeneity, and these are the equations where FP is some kind of idealized P wave source and S source Fs. So these, in other words, this governs S to S interaction, P to S interaction, like that. So basically the scheme is this. Make it into an equation for phi P. You have two equations into unknowns. Solve for phi S here and substitute it there. Okay. Solve for this. Substitute in there. Okay. Well, to solve for this, you don't want to solve it by inverting this. Bring this guy over first, and then invert that. Then you have phi S in terms of phi P and FP. Clear? Bring this one over, and then invert that operator, including the, that's the only thing here. So that GS is that operator. Okay, like that. So then now you substitute, you have one equation for PP, and this is if, and then you can further reduce, you can assume I'm in water, so my source is P. This is gone. Yes, this is a shear source. So this then tells you for a P-only source, if I drop this term, all histories that will, and then you're at some location, P, you're at some location R and omega, or R and omega, and you're at some location R, and there's a source that was at here, what is the P wave that should predict that, yes? This gives you all channels going to S and everything, the way it is, okay? Because there's GS here, okay? There's a S spot here. So the bottom line is you can replace GS in terms of what we call GS0, meaning no VSS term. A series itself, so it's a series within a series, okay? In other words, you can take this, put this as a perturbation, right? It's like a Lippmann-Schroeder, and make it in terms of this operator. And you're only propagating a homogeneous shear wave with hits on that. So first you write the whole story in terms of that, then there's another series where this is substituted in terms of GS0. The bottom line is, it gives you a way to say for a P wave source, at this point, this is what the P wave will be, okay? Through all histories. Then, among all the histories, you can select those histories that are P-only. The thought is that P-only histories will come from reference P and hits. In other words, you're not going to have actual history. You're going to have a set of born, like the inverse, a set of things that make the feeling. In other words, if it has a generators which are P and S in homogeneous media, the feeling is that the P actual will be made from P reference and hits. That it won't, if it has the ability to do P and S reference, it won't look at transverse to make longitudinal, vice versa. So anyway, the idea, you write all this stuff any way you want. You got a complicated V, okay, which allows for more. In other words, in this form, P can enter S. All this guarantees is it started out as a P source and you measured a P wave. But this machinery as it is doesn't make it inside the V, you select. So that reference shear are not in. Okay? That's the whole story. This is in 3D. This is straight from the book with Bob, the 3D version of the elastic linear. So I'm not going to take you through all this machinery, but first of all, what you might, first of all, I got to get out of the mindset that I'm going to always do the inverse. Here you know the medium. So this could be that you put a smooth reference, as long as P and S mind their own business. Yes? You understand? You want them uncoupled. Then that might be okay for some modeling, and then you do a perturbation about it. In other words, here you will know the medium. You're doing modeling. This is a modeling machine we're talking about. So you break it up into something smooth and some perturbations. And the perturbations, if you make them small by the smooth part, then several terms in this could give you a reasonable answer. So I'm going to stop with that. Let Shuli show you a very simple, she just started looking at this, an example of a single reflector and a Born term, meaning one term in the series, compared to finite difference. It's just a step into that problem. So what do we expect? What will happen? It's good to know what we expect. If you have a source, a P source, and you're recording, so this is a P source, and this is a P receiver, P. This is FP. Then this trace will have events. I'm saying the end game will be whatever this is. Some of these will be entire P histories, some will be P and S histories, and so on. Whatever arrives as P, but it didn't have to spend its whole life as P. to enter as P. So every possible history that started as a P source and measured a P wave here, including episodes which are S, will be on that trace. Clear? The Born thing that we're going to be after, the modeling of P only, is going to do only P only events. These that have intermediate episodes where it's P, SP, SP, in other words, P source, ends at P measurement, this event is not our goal. So there'll be a difference between this series expression for P only and what a finite difference would give. That's the goal. And hopefully to be less expensive and full elastic. Because all those perturbations understand give and take with other wave types. We just don't want to, we don't want to predict the other wave types. We want them to influence without following them. Okay? That's the goal. Okay? Jinglu? Okay. So I try to make this brief. The other talks I give today, well, I'll try to make brief too. I don't want to drag you through all these sums. That's basically the point.